So here's the only two equations you really are responsible for. And just knowing the difference is important. You would use this equation for continuous compounding, growing continuously, right? So let's say something's growing continuously at 14%. That's what we're going to explore here. Notice the only difference between these two equations here is e to the r, and that replaces b. So e to the r is the rate, and the rate is going to be expressed as a decimal. So this would be e raised to the 0.14. That is a continuous growth of 14%. Of course, how many times it's growing would be x, but that's just a continuous growth at 14%. That I count. And when I do that, I get 1.15027 and a bunch of other stuff, but essentially 1.15. So if b was 1.15, that would be comparable, but it's a 14% continuous growth would be about a 15% annual growth. All right, you see the difference? How you put this in versus how you put this in, and what the difference means. Let me just explore this E number a little bit and then come back to this. So yeah, here's E. I should put E equals, and it equals this. The limit as n goes to infinity. In other words, as n gets larger and larger and larger, this is the formula for it. 1 plus 1 over n raised to the n power. Now what this number actually is, it's really difficult to discern, because as n gets larger and larger here, this starts crashing. This whole plus 1 over n starts getting closer and closer and closer to 0. Well, if this gets close to 0, 1 raised to any power is still 1. So in some ways, it looks like it's crashing towards 1. But then again, look at this here. Now, if this gets larger and larger, if this is anything over 1, this gets bigger and bigger. So you got this here raised to the n power making this bigger, and this here making this smaller towards 1. So it's a very odd number. So let's just put in n, different values of n up to a trillion, and see what E comes out to be, or what it approaches. Okay, so to do this, I'm going to put equals in parentheses 1 plus 1 divided by C5, which will become C6, etc. Close parentheses and raise it to the same C5. I'm going to let that change. I'm going to let this go on. So when n is 1, the output E is 2. This says take n to approach infinity. So when I get up to 100, I get n is 2.7. When I get up to a trillion, n gets even more accurate. Here, 2.71852350. Now, Excel has built-in n, and you get it by saying equals exp. I'm going to raise it to the first power. Number raised to the first power is itself, so that's e to the first power, and that's what Excel gives me. So see, at a trillion, I'm getting reasonably accurate. If I go to 100 trillion or quadrillion or e to the 90th power, it'll get even more accurate. So e is about 2.718, and that's what it is. So it's kind of amazing. Look. E is like one of the 5 most important numbers in all math. 0, 1, pi, e, square root of -1, considered like 5 most important numbers. So that's how this is going to work, this formula. R is going to be the decimal equivalent of the continuous growth rate. So let's just do another one. Let's do increase by 12%. Continuously. I'm going to type that in. Good thing I spell check. All right, so continuously, I would write the equation y equals e. We'll just make it e is going to be raised to the 0.12, which is just the decimal equivalent of 12. So let's actually do a problem like this with this. Positive numbers first. All right, let's say that we have here, and I'll pull this up. Continuous growth with an initial value of 300, a growth rate of 3.2% for 3 periods, 3 years or whatever. So I'm going to get 300 times E raised to the 3.2 over 100, put it in your calculator, 0.032 times 3 periods. And you might want to put that in parentheses, like that. And put it in your calculator. Let's see what you get. And I'm getting 330.23. Rounded to 2 decimals. Okay. Now that's different if this is compounding, this is compounding continuously. If I was going to compound this and I said do this using this formula, I want a compounding, but I don't want continuous compounding. It would be 300 times 1.032 raised to the 3rd power. And 329.73. So there's a similarity, but this is handled differently. Now I want to do one with decreasing continuously. Okay, now pay attention to this because this is different, right? I'm going to use the decimal, but I'm going to use the negative decimal. So watch this. So my initial value is 500. E is not going to change, but my rate is going to be 0.098. And that's not even right because I need a negative. When you're decreasing, you get negative, and it's going to be for 4 years. So it's 9.8 over 100, but because it's decreasing, it's a negative number in the continuous form. And that is the continuous form. So let's see what we get when we put that in our calculator. And I get, when I do it this way, 337
is going to be leading us in some songs of worship.
Okay.
And as we get ready for that, I just want to take a moment to to talk about the on Facebook. You
So
know,
if it wasn't a
Facebook, and if that's
continuous
working for you,
decay, and
wonderful.
it was just
Secondly,
an
we have
annual or a
form that
period
you
type
can use,
decay,
especially that's
once
helpful
every
if maybe
period,
you're
instead of all the
trying
time
to
decaying,
use like a smart TV, like
or
maybe in
being
your living room or
reduced by
something like that. If that
9.8%, this would still be the same number. But B would be what? Now, you should know what B is, because it's going to
is
be
the case, then our
1
YouTube
minus
channel is going to probably be the most
9.8,
conducive to that.
which would
But
be
if you're joining from our web page, where if you go on the web page and you
912
click Watch Live,
raised
we've
to the
changed
third
that
power.
platform to one that is actually built for churches.
And put that in our calculator, and what do we get?
Maybe if you're on Facebook this
Actually,
morning,
that
if you
should
want, if
be
you're able to
fourth
switch
power,
over and
correct?
switch to that.
And I get
Live, if you go to
345.90.
vineyardboise.org/live, or if you just go to our website and click the Watch Live
So it makes
button,
sense that this
you'll
is
find that in your
smaller
profile.
than this, if you think
If
about
you're,
it, because this is
if you
decaying all
figured
the
out how to
time.
dial in and you're
And
not,
this
and
is
you don't
just
want to mess with
decaying
it
every
this
period. So this is comparable.
morning, don't worry about it.
But this is
We can engage with
continuous.
you either way. But
this
whichever
is
way you're engaging, we're going to
every
take a
time
moment to
period.
light a candle here. And I would
So let me
encourage
put a
you, if
couple
you've,
of ones up
if
here,
you have someone in your
and
home or wherever
let you
you're
try to
gathering, if
guess
you have
what
access to
the
a candle,
continuous
to
decay
have
rate
somebody light the
or
candle is
the
in
continuous
a
decay
reminder
increase, or
of
the
God's
continuous
presence
increases.
in our midst, that as we come to work.
Okay, so here's our continuous exponential function. And here's an example. And what I got to know is the initial value, the continuous rate as a percentage, and the number of periods. So you might want to hit pause and think about this for a minute. I'm going to move along. So that's the initial value. This would be 0.255 over 1, which is the same as 25.5 over 100, or 25%. And the number of periods is 3. Okay, so let's do this one. Now you might want to hit pause. My initial value was 12,300. My continuous rate is negative 5.5%. So it's decreasing by 5.5%. And the number of periods. The reason I say periods, it may be every day, every month, every year, or whatever. Every 10,000 years, it's decay of a radioactive material.